Hey guys, it's Friday. My voice is tired. And I have a long sparkle night ahead of me too. I'm saying too because I know some of you do also, and I know some of you have already had a long week. Please don't make me yell. Gracias. In the back of our homework spirals, we're going to try to do 2 shell problems. However, from yesterday, does anyone think I am under the false impression that you guys are all masters at shells? No, definitely not. And if I were just to ask you, you should be saying, no, I'm definitely not. Which means today, does some help need to be given? Yes. And possibly to the concept itself, not just to the homework problems. So to help you with the concept itself, we have 2 problems in the back of our homework spiral that we should all be very tuned in on because this topic is still very new to us. So we're going to do these in the back of our homework spirals. You guys are getting those back of your homework spirals ready, I hope. Ooh, color coding is off. But first, I want to show you something. One of your classmates was like, I am not sure I have the concept of shells down as far as even just the general idea. I know I have that cool little shapey thing. But even though I have that cool little shapey thing, that doesn't necessarily mean that you totally understand what's going on. And so, if we do have some sort of region, okay? Some sort of region that's being, ooh, you guys can tell from the picture, can't you? How is that region being revolved about what? The y-axis. True. Then it generates that 3-dimensional solid. And how does shells decide to break it up? Instead of slicing across and having little baby circular slices and then bigger and bigger and bigger circular slices, like a loaf of bread, turning it on its side and then let's go. Actually, what's something circular, turn on its side, let's go. Cucumbers? I don't know. But anyway, instead of slicing it perpendicular with a knife, slicing it perpendicular to the y-axis, or flipping, you could say flipping the axis and going down, what do shells do? Do you see it? Shells say, hey, we're still taking areas, but instead of taking areas that are going across, they're areas that are folded around. Kind of like a piece of paper that's been folded around. And a piece of paper within a piece of paper within a piece of paper. And what do integrals do to those 2-dimensional pieces of paper? Give them some thickness. Integrals give them some thickness, so it's not just infinitesimally thin. Because wait a minute, with paper, couldn't we technically, now we might use a lot of paper, but couldn't we technically make those really, really tight and basically make that shape with paper? Right? Couldn't we just like fold and then a little bit bigger fold, a little bit bigger fold, a little bit bigger fold, and if we had tons of paper, we could eventually make that. Because paper has what? Thickness. And how thin paper is will make it a very, 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 very good approximation. If we could actually do the dimensions of all of those pieces of paper and add all of those pieces of paper together. However, that's not what we're doing. We're not doing papers and adding them all together with all of their volumes, because paper does have a little bit of thickness, which is why cardstock feels a lot heavier than printer paper. That feels a lot heavier than paper mache. But anyway, integrals give it thickness and then accumulate, but we can't just do pi r squared because that's not what this guy is. If I take one of these and I cut it and I unfold it, what shape does it have? A rectangle. And a rectangle has an area of pi r squared. Discs and washers, we are putting areas within the integral, giving it thicknesses with the x and y, and the integral is accumulating the volume. We're doing the area of this little guy cut and then extended. How high is he? Well, the way this one is oriented, he's up y. And how long is he? 2 pi. Well, isn't this technically my height? And isn't this usually 2 pi r? But I need this in terms of x and y. So guys, for this one around the vertical axis, what would my radius be? The x. So for this guy, the dude that I'm doing, the y would be how high, and the x would be my radius. My y would be how high, and my x would be my radius. Now wait a minute, would this one be in terms of x or in terms of y? Because my thickness would be added this way to give my cylinder thickness. Because I I would want my cylinder to have thickness. My cylinder needs thickness. And that's not perpendicular to my y. It's para-shell to my y. So wait a minute, if everything was in terms of x, I would need 2 pi integral. Remember, all variables need to go inside. 2 pi is because of that dude. 2 pi r, oh, that's x, times, I can't put a y in an integral. But isn't y going to equal a function of x that I can do f of x top minus, what's the bottom of this one if it's only down to the axis? Got it. Is there a squared in here? Well, not specifically, because, I mean, I don't know what's in here. There might be a square. But theoretically, the math might be easier to solve this than it would be of a pi r squared. Might not be. Maybe just would be easier. But that's the idea of para-shell. I'm taking these little pieces of paper, I'm folding them around, I'm accumulating them throughout. My integral gives that two-dimensional, absolutely no thickness area, thickness, and then my volumes can be accumulated with the integral. So, you don't need to draw the pictures necessarily, but can you and your group set up but do not solve, set up but do not solve how to find the volumes of these two-dimensional areas being rotated this way or that way? And just in case you are thinking of the old school, this one would have been a washer. That helps it all. And this one would have been a disc. If that helps it all. Ready, set? I can't give you tons of time. I'm going to say 4 minutes. What can you and your group do? Because some of you can explain how you have figured out how to solve it better than I. And some of you, the discussion alone will help you be more ready to hear the solution when it comes. Go. Don't use this. Don't use washers. I'm just saying what it would be. Use shells. Yes, the one on the left is easier, so please don't just go to the one on the right. It's harder. Just like at this one. For the first one, 2 to 4 are the x's. Oh, it's not shown at all. Let's go 1 to 4.
Yeah, 1 to 2. Because you're rotating it around y equals or x equals 0. You're rotating it around x equals 0, so the up.
Yes, your notes have an endeavor card for this, don't they? I know the wall doesn't, but your notes do. I know, I'm sorry, the wall doesn't yet, but the notes do.
Oh, I was thinking about it like the washer. Why?
X minus 2 or minus 2. I think it might. Yeah. Okay, so it's just X. The function. Minus. Yeah. I think that's what
I'm just thinking about it like the washer.
That's 2. Okay, so
oh, she wrote it up here.
that's just X equals 1 and 2 y. That means the radius of r, y times. Oh, Well, I think we have to change the bounds.
It'll be minus 1/2 or 1/2. Because x equals 1, y equals 1, and x equals 2, y equals 1/2.
Wait, so when
Wait, no. Maybe 1 is 0.
wait, when you plug in 1, y is 1. When you plug in 2, y is 1.
Oh, no, that's just
Like
that.
that.
But that's like still. That's just that little top part, not the whole thing.
It has to do with where you set your bounds.
So I'm gonna go 0.
Wait, let's do the radius. So
No, because basically you're making a bunch of these. So it's not like each cylinder is just like one radius. So it's like yeah, because
X.
yeah, and then
I think it's just X.
it's gonna be radius.
Wait, the second problem? Yeah, so it's in terms of y.
But you're around the axis. Limiting how far it is from the
Oh, shoot, yeah, you're right.
Is it right minus left?
So the two things are x equals 2 and x equals 1. Is that it?
Wait, when you revolve on the x-axis, it's in terms of y, right? What do you have?
the axis revolving around y. I'm not sure that's the
Oh,
It's different from
it's kind of tricky. Did you do the homework?
I just don't understand how you can make it
I mean,
Yeah, I don't get the r definition of x.
I think all we could do,
it's just all
all we can do, or do let's see the I remember the PPT.
What? Oh, you stopped to get me that.
I keep reminding you because it's my own demise.
Nothing to worry about 2025. You're gonna figure out is also to be in terms of x. So wherever the axis is, you go somewhere inside the area and go parallel. You're not going perpendicular, parallel. So that has thickness dx. That's why I had that written. So when you guys were trying to figure out bounds, weren't you looking how far left and how far right? And what'd you get? Oh, you had it. I heard you guys saying it. What were your bounds? 2 to 4. Yeah, you're right. It's a weird, nasty washer problem. I know it would be gross, and you can't just go from 2 to 4, but with shells you can. It's from x to x, from 2 to 4. You're exactly right. How would I know the 2? I would have found the intercept, and the intercept is 2. I would have set these equal, the intersection is 2, 0. So 2 to 4. Now, my r. Some of you were talking about your endeavor card. But can't you see it in the picture? If I was to show a representative x and y right here, isn't x the how far over? X is the how far over. Whatever cylinder you do, how far over gets me the radius for that cylinder. But isn't that in your endeavor card too? I had to change it yesterday. If you didn't get that change, it might have gotten messed up. Sorry. But x is my radius. What's my height? The y! Because it's from the 0. Technically it's y minus 0, but I don't want y. I need it in terms of x. Oh, This dude, technically minus 0. What if this region went lower? Well, it'd be y minus negative 1 or y minus negative 2. What if it went higher? It'd be y minus 1/2 or whatever it is. Dx. And some of you are a little sad because you're like, I wish this was squared. It's a square root. If I had to solve it, ugh. Oh, but come on, it's u sub. U equals x minus 2. And that could be square root of u with like another u, and then you would distribute your powers. Anyway, it's possible. It's possible. Once again, my job in these is not to teach you how to integrate, right? Questions? How many people got there before me? Okay, it's like half the class. The rest of you guys. You see? I have my function. I have my 0. I'm doing my top minus bottom. I can't call it an R anymore. It's not. It's a height. But I have my top minus bottom being applied, but it's within the 2 pi RH formula. What's different with this one? Pause. If this was a washer's problem, would it have been more involved in the integral? Yeah, you would have had an r squared and an r squared, right? So you would have had a big R squared minus a little r squared. Shells simplify most, if not all, washer problems. Because it lets you move from the beginning to the end of that region without having to do a whole minus a hollow. So your orientation switch allows you to translate through that region smoothly. How hard would this disk problem be? Easy, because it's flush. 1 pi r squared. So what do you think maybe the shell method might be? Hard. Shell makes easy problems hard and hard problems easy. Hence why we don't want to always use shells. So what am I warning you about this one? This guy, the yellow guy, is right. But he's only right up until I have different boundaries. You guys see that everything changes right here? Because if I was setting up, first of all, what do I have? dx or dy? I go parallel, and I give that parallel slice thickness. Is that horizontal thickness or vertical thickness? Vertical. I went up to make it. So dy. Okay, so if you want, you could go ahead and say, okay, I know 2 pi, then my a to b, whatever, is going to be an r of y, h of y. If that helps you keep track of everything. But sadly, I'm going to go ahead and have a, wait, y's? I need this then. I need y's to be my bounds. Oh, she just wrote 2. That y is 0, no big deal. This y, at 2, what is my height? Not pi, 1/2, right? So at 2, plugging in, isn't that a 1/2? And at 1, what is my height? So I have from 0 to 1/2, and then I have from 1/2 to 1. I have from 0 to 1/2, and then 1/2 to 1. For my 0 to 1/2, how's my little cylinder dude? Well, to be honest, he's actually a perfect cylinder dude. Because he has no curvature to him. He's just cylinders, 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 cylinders. It's going to actually just be a cylinder. So some of you might be able to be like, hey, that's a geometric solid. I could figure out that volume myself. This little extra curved volume is the one that's weird. That would take a lot of visualization to do. That some of you can do, and some of you it's like, oh, that's rough. The rest of us, we can just say, all right, fine. What's my R and what's my H? Well, R is awkward. It's up and down this time. But my R is Y. Yeah, my R is my Y. And what is my H? Not even X, because I'm not even at the points of the. Isn't it just always going to be 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, right? They're all 1. All of them. So this is going to be a little bit weird because it's just Y times 1. But then, as soon as I get up to this little blue dude, well, everything got just a little bit more complicated because the little blue dude, I think he was this one, I don't remember. The little blue dude, he is going to change. Based on that little curly dude. So what is his R? Well, wait a minute. What am I going around? Oops, sorry, I made it a little bit too extreme. I'm going about the axis. His R is also going to be Y, just how high, right? All the Y's between 1/2 and 1, hitting on all of those at their appropriate locations. But what is his height going to be? Not 1 anymore. Oh, now it's getting smaller and smaller and smaller and smaller. What is it? Okay, this is this side. This side is x equals 1 over y, getting it in terms of y. But does it go all the way to the axis? Is it that entire x value? Minus. What's on the left? Now, didn't we just say a disk would have been easy? So if I do have you do a hard shell method where there needs to be a split in orientation, it's only because I'm making sure you really understand how to do shells. Does that make sense? Because on an AP test, you would choose to do disks, hopefully, all day long. It's flush and disk, please. Shells we only do when we have to, or if some of you get really good at it, to simplify all of the work necessary for washers. The hard thing is the AP sometimes just says, hey, which of these will find a volume? Maybe they have a shell that would, and maybe they have a washer that would. Maybe it's like A and B or something like that. Or maybe they make one little mistake in the washer orientation, but then the shell is perfect. Oh. Meanies. I think there was one last year where I said, oh, there's a 2 pi in there. Can you ignore that? Because I think that's a shell method. But you probably don't remember that. It was in a multiple choice question that we had. Anyway, could we keep on doing shells all day long? Yeah, we could. But can we go peek at homework because some of it was disks and washers and see where you got stuck? Is that okay? All right, have it ready over here. Yeah, see, I have all kinds of... Oh, look at... Ooh, hey, washers all day long, but maybe shells would just let me... Anyway, you guys probably don't have enough visualization to really help you on those ones. I think some of these are maybe some of your homework problems. Let me just kind of leave them up here while we go and peek at discs and washers and shells. Oh, where are you? Oh, he's reloading. Sorry, he's coming. Discs and washers and shells. If some of you guys are falling asleep, go do something productive. Go open up Google Classroom. Write down your 8.3 homework if you haven't yet. Your 8.4 homework if you're like, wait, there's an 8.4. Maybe your Chapter 8 review homework. Did I have that pop up today just because? I think so. Shells. How many evens did I give you? I think 4, and 2 of them are multiple choice. Why? I wanted you to be able to grade and see and look and process the solution. Number 4, the final answer should have been 16/15 pi. They said you could solve by hand. Oh, it was a cross-section one. 16/15 pi. Number 12, I think that's the final answer. Yeah, 128 pi over 7. So 16/15 pi, you have 128 pi over 7. Another cross section? I think I could have just been a pi square. Yeah. And then number 68 is E and 70 is D. I'm ready for questions. I was hoping most of the questions you already had, you brought to class with you. Oh, come on. We have to have questions on this if you tried it. And if you didn't try it, you should be making me think you tried it, just so I don't get mad. Which one, AJ?
35.
Perfect. 770? Okay. Anything else? Okay, I'll start with those two. Then if we have extra time. Maybe I'll cover one more. I think this will probably take up our time as far as what we can spend on homework though. 35 says use the shell method. No, there's an A and a B and a C and a D. What are they trying to make sure that you really understand? What was I trying to make sure that you really understand by giving you the problem? Didn't yesterday, when you guys had 4 different disc and washer problems, didn't it really prove whether you could do the discs or washers in whatever context? Right? Same thing here. I gave you a similar problem with shells. So let's go ahead and get this guy down. We have 35 and then yours is 70. And that was a multiple choice, I think, right? Okay. Ugh, come on, computer. Killing me, Smalls. Come on. Come on. Okay. I'm going to go ahead and steal this dude. I already have him ready and he's a nice copy of him. Sweet. Let's go ahead and use him. Okay. We're just going to set up. Yeah? We're just going to set up. The letter A. Okay. We're going about the...
Wes, what are you doing? You're not practicing soccer.
I don't. Let's just keep bouncing about.
I am, and then Mike did exceptional.
You guys at least get the difference in how we're slicing? I'm not slicing perpendicular. I'm slicing parallel. So how do you make a parallel line? And make it inside the area. Okay? So parallel. What do I do to that parallel? I give it thickness. Ooh, yeah, dy. Parallel, make it thick. Oh, okay, fine, dy. If you want to, if visualization is helping you as far as the R's and the H's, you can make a little cylinder and be like, yay, go team. If that helps. If it doesn't, okay, let's just see if you were to plug into the formula, right? I would have 2 pi dy means R of y, H of y. Hey, guess what's going to be y? Huh?
You said, like, guess what is Y? You said R.
Guess what is the... I didn't say R? Okay, I'll say it again. Guess what is the R? Guess what is the radius? Y. If you want to look at the picture and know that it's Y. But the radius is either X or it's Y. Now we have to be careful because if this moves and if this changes, which it's about to do, it might be Y minus or Y plus, but we put that in the endeavor card to help us. But in this one, it's Y minus 0, so sweet, just Y. That's my radius. We'll come back to our bounds in just a second. We just need to figure out the beginning Y and the ending Y. But the height, what's that going to be? Well, the height is awkwardly the other direction. Radius is the y, so the height must be the x. Well, who is the x? 12 y squared minus y cubed. Okay, so 12 y squared minus y cubed. But why did I leave room for a minus? That's on this side. That's on the curved side. What's on the other side? Well, in this one, what am I lucky is on the other side? 0. Sweet. Got it. 2 pi r h. Got it. All you need to know is how low do the y's go? 0. How high do the y's go? 1. Done. How low do the y's go? 0. How high do the y's go? Done. Now what changes if I have a different horizontal line like letter V? The radius will change. Because if I was to change this, and I'm just going to go ahead and get a clean picture so we can see it. If I was to change this, I'm still going about a horizontal line. Just my horizontal line this time is y equals 1. Now I still slice parallel. That doesn't change. I still have a thickness of dy. That doesn't change. But where is this going this time? Not going down and around, but going up and around. Okay, so wait a minute. radius this time? Oh, I thought my radius was just always going to be y. Isn't my radius this time? Here's the nice thing. Where's my radius always? Axis to curve. Axis to curve. Axis to your representative, wherever he is. You don't need the three-dimensional. You don't need the three-dimensional. I just need to be able to go from my axis to my curve. So is that perpendicular line still important? The one that we always did. The one that we went from the axis out. Is it still important? Yes. What is it important for? The radius. Because to get from the axis, well, I didn't have to go all the way through the shaded area like a washer does. I just had to get to my representative to look and see what's going to happen every single time I have another one. So I went up to my representative one, but I didn't need to go through. And then this one, I went down to my representative one. It wasn't so much I was trying to go through. Yeah. I just went to the location of the one that I had drawn. And then I have my Y still. So I have my R and I have my Y, my H. So in this one, if I was just trying to set up, I would have my 2 pi. I still have my Y's of 0 to 1. That didn't change. My radius is going to be something to do with Y, but what's on top of my radius is 1. It's 1 minus Y. And what's my other guy going to be? Well, ironically, nothing has changed. It's still my curve, my x equals curve minus my x equals 0. So 12 times y squared minus y cubed. Now remember, we're doing this to try to help you visualize. This is the exact same curve, just being spun different ways. So what if we were to do letter C? Y equals 8/5. Where's he at? Up here somewhere, right guys? Like 1 3/5. What changes? Nothing. Well, I still do my slice. Parallel. I still have my thickness, dy. Ready? I'm not going to do the three-dimensional thing because it's too hard for some of you. Is this still important? Yep. So draw it. Who is it? R. What's the other guy? H. Sweet. So let's write it. 2 pi. What are my y's? 0 to 1. What's my r? Who's on top? 8 over 5. Who's on bottom? Y. Remember, that dy. My height. What's on the left? X equals. And what's on the right? Did some of you have a lot of work to try to get down dips and washers? Yeah, but it all happened last year. This year was review. Now maybe you still need to review more, but yes, it's hard. I know it's hard because you're doing new visualizations. So can anybody, without even having the picture and like drawing the picture, what do you think D would look like? Looking at all 3 of the other ones. Once again, it's just that. Sorry, that was C. My bad. Looking at all 3 of the other ones. What stays the same? What could you fill in? 2 pi. Great. What else? Integral from? Still a dy. Good. What else do you think is going to stay the same? Looking at all the others. The height. Yeah, this stays the same. The 12. What changes? Would it be negative 2/5 minus like all of these guys were? No, because negative 2/5 minus is going to make negative because all of these y's are positive. I don't want a negative volume. Why would it switch and be y minus a negative 2/5? Because where would this guy be? This dude would be down here. So when I drew my representative slice, how would I be going? Now, I'd be going up. What would be on top would be my y. What would be on bottom whenever you have a radius, you're either doing top minus bottom, axis minus y, or top minus bottom, y minus axis. And that's where we started. We started at a y minus axis, but it was y minus 0. Could you write yourself a note about the radius when it's y, right? When it's y, and it's somehow off the axis, it won't just be y alone. So whenever you have dy and my radius is a y, if the axis is on top, it'd be axis minus y. If the axis is on bottom, y minus axis. Yeah, you can make yourself little tricks, little hints, little clues. There is a system to it. The visualization, the three-dimensional, is not necessarily necessary, but the drawing of the axis and the extending from the axis to the region, whether it's down or whether it's up, that is necessary. But if you know my radius is y, and then it's either, okay, number minus y or y minus number, it'd be okay. And to be honest, if you're able to use your calculator, it doesn't actually matter which way you subtract the axis. You could throw in an absolute value and everything would be just fine. But that's if you're using a calculator. If you're trying to make it match, well, maybe if you had it this way and the answer key had it that way, if you had it the other way and the answer key had it this way, I guess it might mess up which one you make it match to. But the key is that you realize if the axis is somewhere off the x-axis, if the horizontal axis of revolution is somehow off, there's going to be a subtraction in that radius. So, here's a question. Well, let's see what number 70 is first. What's number 70? Wherever he is. He's on the next page. Is this a vertical or a horizontal? Ah, it's another horizontal one. Poop. That's no fun. Sorry, I wanted it to be a vertical one, so we did visualize a vertical one. We have enclosed by. What's y equal e to the x look like? What's y equal e to the negative x look like? Isn't it just a horizontal flip? Wait a minute, it says enclosed by. It's not enclosed by. Pause and x equals. Do I have an enclosed by? Yeah. Where is he being revolved? X-axis. Oh, sad day. I want my yellow highlighter. I don't know if I can do it. Oh, here he is. Okay. Is this guy out important? Yep. Parallel. Ew. Oh, it doesn't make me do shells. Do you guys see 2 pies anywhere? Oh, thank goodness. Whew. I didn't want to do shells. So if I don't do shells, what do I have? Sorry. I have a big R. And I have a purple. Blue words instead of purple, right? And I have a little sweet. So then I can go ahead and not even have to worry about all the crazy shell stuff. That was going to be a nasty, having to split up at the intersection point. It's a nasty shell one. Because the orientation switches when I go parallel. Big R squared would be this dude, which is e to the x, minus that dude, which is just 0. And then little r squared is going to be the other dude, which is e to the negative x on top. And then bottom is 0. So I end up with a pi. I better have a squared minus a squared. Couldn't that already take out quite a bit? I have a 50% chance of getting it right just by knowing it should be a squared minus a squared. It's a washer. Look at all that hollow space, right? He doesn't even have pi. I didn't even think hard. Should I double check that I'm right? My big R is a positive e to the x minus 0. My little r is an e to the negative x minus 0. Wait, how did they? Oh, a power to a power you multiply. Stickers. But yeah, letter D is the answer. Kiddos, we did not get to do some vertical axis like we did the horizontal axis with our shell method. I think we've really busted out the horizontal axis as far as all the different ways that this can happen. I can have the x-axis, I can have one that's above, I can have one that's below. We didn't do that with vertical. Maybe that's something great that we do next Monday or Tuesday, where we're trying to review for our Chapter 8 test. But for right now, Oh, I had number 70 and I was all ready for them. That's okay. What on earth is the very last concept in chapter 8 and the very last concept of the semester? Is that a card number? 8. That's right. Oh, our numbering is good. CalcBC somehow we got an extra forever card. Yeah. Let's just put product and quotient together and put it separately. We'll figure out something. Chapter 7. Wait, what? What chapter 8? Did I say chapter 7? The very last concept of, the very last endeavor card, I should say, of chapter 8 and of the semester. Arc length. Thanks, John. Arc length and surfaces of revolution. Wait, surfaces of revolution. Oh, stink. Is there an arc length card and a surfaces of revolution card? Maybe I should get them all on one page. You guys can take a picture of it. You can have your endeavor cards all up to date as you guys are studying your forever's endeavors.
So are we having a chapter 8 test and a forever final?
It's on the calendar. I said you should check out last Monday, or this past Monday, but let me go see. I believe so. I believe it's Wednesday. However, having a test on chapter 8 is meant to be to your benefit and the benefit of your grade. Just take that kindly. It's meant to be to your benefit and the benefit of your grade. And maybe by having it be the Wednesday right before finals week, I might give certain allowances to try to make it a good test score. I'm not saying what it is. You guys all guessing and assuming of it?
We are in shock.
Wednesday. Yeah, Wednesday. I'm finding for you the Surfaces of Revolution card. ¿Dónde está? Aquí. It's a pretty card. I like the Surfaces of Revolution. There is something really cool about these two cards in this section. In Chapter 8, Section 3, Areas and Volumes, was orientation really important? Yes. Whether you were doing dx or whether you were doing dy, changes drastically between discs and washers and shells with perpendicular and parashell. The orientation is crucial. Here's something really cool with Section 8.4. It doesn't matter. Do whichever one is easier. And just plug it in. What? They give you an f of y, or whatever, call it g of y. Sweet, take a derivative, plug it in. They give you an f of x. Sweet, take a derivative, plug it in. Wait, really? And what does surface use? Do you see it? It uses arc length. What does surface use? It uses arc length. Surface area. What's on the surface? What's on the surface is what's on the outside. What's on the outside doesn't worry about the volume on the inside, but just the length, arc length of the outside. This is basically a Pythagorean theorem having to do with tangent lines using the differential. Gets a little interesting. It's kind of like a Pythagorean theorem using a differential, using the tangent lines. And the tangent lines, if you want to look over here, in some ways, shapes, or forms, those tangent lines, okay, this is showing a secant line between, but that's an approximate. If we can use tangent lines instead, well, we can make it exact, and then those linear portions get made infinitesimally thin, and so it becomes smooth instead of fragmented like Euler's method, kind of. Surfaces of revolution say there's this thing called a frustum, which basically I need the circumference times the circumference, taking that ring and bringing it around, the circumference 2 pi r times the arc length. I know, the ideas are actually kind of rough as to how this accumulation happens, but the forever cards are actually pretty easy. Because once again, dx versus dy doesn't matter which one you choose. section of chapter 8. But if you have these two endeavor cards written down and you're already studying them, even though the idea as to where it came from is complicated, the application is, oh, you just plugged in. Oh, you just plugged in. Oh, you just plugged in. But wait, to plug in, what am I going to have to do to my function? Derive it. Oh, you derived and then plugged into the formula. Derived and then plugged into the formula. That's all you're going to see me do on Monday, even though it's kind of weird where it came from. Do you see it, kind of? Formulas. Then you take functions and derive them, and then plug and shove. Kiddos, I know it's weird, and I know you feel like just maybe avalanche on top of you from calculus BC, but I promise 8.4 isn't as bad as you think it is. Okay? Shells might be. But they do make nasty monster problems easier. Do what you can this weekend to catch up on 8.3 if you didn't finish. I'm pretty sure some of you didn't do that homework. And then 8.4 to write your endeavor cards down. And to be honest, you're plugging and chugging. You could probably bust out the homework and not have to worry about another calculus homework this semester. Oh, boom, boom, boom. Bye, guys. Another section homework this semester. I should know to watch my words carefully in this class. Bye, guys.
Hey.